Hello, everyone. Welcome back. Hope you had a good break. Next talk, we have two fantastic speakers, Jose Palafox, Director of Business Development and GitHub from GitHub, and of course, Natalee Webb, Senior Program Manager at GitHub as well. They're going to be speaking on securing credentials at GitHub and we're really excited to hear about this because we know how much of you use GitHub, including myself. And yeah, looking forward to this talk, guys. And feel free to put comments and questions in there, and then we'll go ahead and answer them after the talk. Enjoy.
Jose, you might be muted.
Okay, how about that?
Perfect.
Awesome. Thanks for having us back, Mel. When we came back, or when we were here a year ago, we hadn't launched GitHub push protection, which is really exciting. So I had even a tiny preview about it in the talk we did last year, and so I'm really excited to come back and share how some of the metrics are looking and how that feature rollout's been going on. But we've been plugging away hard here at GitHub on securing API credentials on GitHub.com. So this is a presentation both about what we're doing on GitHub to secure API tokens that you may accidentally leak or leave in your Git commit history. It's also about our partner program and kind of the way that we work with third parties that create API tokens and how we can collaborate with you to help improve account security on github.com. So super excited to chat with you today. My title's changed. Mel introduced me as the Director of Business Development, and that is what I was doing until just very recently. And I just took a new role supporting our West Coast sales organization here in the enterprise segment. So covering some of the bigger West Coast accounts that we've got here at GitHub and helping them adopt the product. I've been working on secret scanning in the program we're going to talk to you about, though, for the previous 2 years. And so I'm really proud of the work we've done. And I've been able to collaborate with Natalee for the last year and a half on it. So I'll hand it over to her to get us kicked off.
Thanks, Jose. As Jose said, I'm Natalee, and I'm the Senior Program Manager for GitHub Secret Scanning Program. I'm super excited to walk through what we've been doing and helping you all help us secure the world's software. So quick run through our agenda today, what we're going to be talking about, give you a little bit of background about what we're doing at GitHub, who we are, walk through our detection process, a little bit about our remediation, and the key part for us is how we can all get on the front side and prevent secret leaks. Then we'll give you a few takeaways and what you can do next. So a quick look at what we've been doing. We believe that we are where the world builds software. Last year, we hit a huge milestone, reaching 100 million developers on our platform. And what that means is there are more and more opportunities for people to leak their secrets on our platform. We're trying to secure the entire internet, not just private repos. And here's what that means to us right now. This is a quick look at what our secret scanning program has grown to do over the last couple of years. Key callouts here on the right, you'll see how many millions of secrets we've detected in public repos. And we're going to go into detail here in just a minute about how we can help you help us and everyone that's using your tokens make sure that they don't leak those and become part of these statistics. So we're not just trying to secure the private and public repos, but GitHub truly cares a lot about the open source community. As you can see here on this graph, in 2022, we issued more CVEs for the open source community than all other security vendors combined. So that's also a focus for us, is not just what is somebody doing in their free public repo or their organization's private repo, but what is that open source community doing when they interact with each other. So let's get into it. How many of you have made an error at work this year? I'm definitely in that group. And how many of you made any errors in your code? Got some comments on a PR, some feedback? That's how most of this starts, human error. So let's talk about how that human error happens, how those secrets get leaked. The first way, and most often that we see and hear about, is on accident. So imagine that I'm doing my development work. I use my credentials for a quick test. I work a little bit too quickly. I commit and push my code, and I forgot to take those credentials out. Bam, they're out, they're leaked. It was an accident. Secrets also get left in Git history. So let's suppose that Jose is my admin and he's remediating leaks and removes the secret from the main branch, but he forgets to scrub the entire history. It's still going to be out there. And secrets can get leaked intentionally. Sometimes this might be malicious, and other times it might be a student who's doing testing and leaves a token in their code and thought that that's what they were supposed to do without going and taking it back out. So there are a lot of ways that we see that our secrets are getting out there, and that will allow sometimes other actors to take a hold of them that we'll talk through. We're definitely seeing, and I'm sure that you all are hearing about this too, more and more tokens are being leaked every year. A recent rapid API survey of developers found that API adoption is increasing across all industries. I'm sure that you all are part of those and that you're using APIs more and more than you used to. 70% of the respondents said that they're going to rely on APIs more this year than they did last year. So we're definitely going to continue to see this trend continue moving upwards. More and more companies are moving to the cloud, so they're more likely to use API keys and possibly lose those keys. And also we require API credentials more and more instead of usernames and passwords for CLI credentials. Again, moving us upward in this trend. Secrets don't just leak in code, though that's about 85% of the secrets that we see is in code itself. But from GitHub scanning billions of commits, we've also learned that tokens and secrets are being leaked in other places. We see them in commit metadata. That might seem a little surprising, but it's really true where we see it. So again, let's assume that I'm setting up my IDE on my machine. I'm setting up a new project. I am supposed to enter my Git username and email, but I actually accidentally put in my username and password. Boom, muscle memory. I've just made a mistake there. We also see commits or leaks of tokens in other sources, pull requests, comments, even issue descriptions. I'm sure that you all have seen these headlines the same as us. More and more we are seeing reports of a single secret causing millions of dollars, thousands of users being impacted or lost because of these leaks. Let's walk through a quick real-world example that we've seen recently. So, SolarWinds, at a very high level, they exposed a credential that gave hackers access to their servers. Those hackers then had access to the servers, which gave them access to all of the customers that were being served. This is one single leak we're talking about here. Within this leak, 18,000 plus customers were impacted. Microsoft, the Department of Treasury, Intel, some of the customers of SolarWinds whose credentials were leaked and had access to because of a single secret coming back to SolarWinds. So I'm at GitHub and I'm thinking, well, I'm keeping my code safe by myself, right? But if I'm a customer of somebody else who has a breach, then I might be impacted, even though where I'm working, I think I might be safe. This is why it's really important to take care of all of our secrets, because it only takes one. Let's walk through for a few minutes how we can help you detect your leaks. So here's a real world example that we did. Say that you're working on your project and you use your GitHub token to authenticate yourself. You accidentally paste that secret into your code and push it to a public repository without even a second thought. So now that secret's leaked in a public repo, what can we do about it? Here's how we detect your leaks and help you with that. So with our service enabled on github.com, we're going to scan the public repositories. We're going to notify the provider for that leaked secret. And then you're going to see an alert in the UI under the security tab. Over the last 2 years, we've seen such a huge exponential growth in the number of repositories where secret scanning is enabled, helping us to detect, and in a minute, we'll talk through remediation of those secrets that have been leaked. So let's walk through the actual workflow. This is how we scan a public repo. A user pushes their commits. We search for those commits that match our specific patterns that we've onboarded into our secret scanning program. For public repositories, we automatically scan all of the code for our partners' patterns. Some examples of those are AWS and Slack. Our partners then choose to revoke and or notify the users of those leaked credentials. These scans, while it might seem they might take a while, they usually take less than a second. So we can very quickly catch leaks. Let's walk through what would happen if we didn't do this. So we're going to walk through an example of us leaking an AWS token and what happened with it. We leaked the token. Immediately, we got an email from AWS telling us that a credential was leaked and what our next steps are going to be to take. For our case study, we decided to ignore this email. We were transparent with AWS about what we were doing, what we were testing, but we just wanted to try and see what was going to happen with this token out in the wild. Take a minute and think about that. One token out in the wild, what do you think the impacts of that are? We thought it was going to take a few hours, a half a day, maybe a day until we saw something happen. So we took a little break from checking it. This is a screenshot of our inbox of what happened. Within 1 hour of leaking that secret, we had 17 attempts to use the credential from random users or bots. These aren't spam. They are the notifications of actual use of that one credential that we leaked. Of course, we monitored our credential, and just for this one scenario, here's the impact with the downstream charges. About $81, again, that's in less than an hour. So imagine if you had that secret out in the code for an entire day or a week or even longer. You would easily see that these charges would rack up exponentially. Again, in this case, we were transparent with what we did. Our account was flagged, and we were just trying to show what the impact of this was. So the detection is great in theory, but in reality, there's a big problem with detections also, and that is false positives. Everyone gets a ton of notifications already. How many of you look at your email and just the sheer number of your inbox makes you walk away, ignoring most of those notifications that you have, whether they're important or not? Alert fatigue is real, and we care about that. I certainly feel exhausted when I see 50 emails. Can't imagine in this scenario, if we kept that leaked token out there for a week, how many emails we would have gotten in our inbox that we would need to go through and clean up. So we want to strengthen developer trust in security. We want to reduce the noise. That means that we want to help increase the strength of the tokens so that if they were leaked, it's going to make it less easy for someone to take advantage of it. Let's take a little bit deeper look at that. As I mentioned, when customers first enable secret scanning on their private repos, we find about 70 historical alerts. Let's assume that we have a 10% false positive rate. That's still 63 or more real secrets that were out there. So why do we care about that so much, though? We care Because the secrets that we see with a higher false positive rate, they have unstructured patterns. Think of a password. You can still scan for passwords, but secrets with less structure mean they're less identifiable, which means they're harder to accurately detect, as we've seen over the last 5-10 years with passwords being checked. You can't use password 1 anymore anywhere to log into something, I don't believe. The same thing is true with secrets. We want to help keep the high positive rates lower, which is going to mean more precision. So here's an example. The top one is a GitHub token without any extra work to strengthen it. The bottom one is an example of where we've added a specific prefix going to make it more identifiable and cause less noise and less false positives. We also added a 32-bit checksum, which again is going to even more reduce the noise and chance of less false positives with this token. One of our partners, DigitalOcean, took these same steps after we gave them feedback. Initially, this is what their secret pattern looked like, and then they adopted a prefix as well to help make this a more identifiable pattern. They also had high entropy or randomness within their token, again, to make it less identifiable. These are some of the steps that we encourage all of our partners to take with their patterns, and certainly encourage all of you to do the same. Let's take a look at how we remediate the secrets once they're out there. What kind of action do we need to take? First, we need to assess. If you're on the security team, you probably need to loop in a developer to understand how that secret's being used. If you're a developer, reach out to your security team to understand any steps you need to take. Rotate. We encourage everyone, once they find out that a secret has been leaked, to rotate those keys. And finally, revoke them. Turn them off. If they stay out there in the wild, nobody can use them to do anything. This is truly the only way to prevent further unauthorized users, is to fully revoke the leaked secret. But there's still more work to do. How can we totally prevent leaks from happening in the first place?
Yeah, and this is a big challenge that we took on here at GitHub, is figuring out how do we pivot the model. You know, what we've been sharing with you is kind of a reactive model. You contribute some code to GitHub. We scan looking for, you know, regex patterns that match our partners and see if there's been an API credential leaked in that commit. If we find it, we flag you. But what if we could scan earlier? And that's what we tried to build with a feature called push protection that we launched in April of last year. Right as I was doing this conference, I think last year, we had just started our public betas of this. But now what happens is if you attempt to commit a secret to GitHub and the organization that you're contributing to has, you know, fiddled and set the settings for secret scanning, which you'll see in large open source projects and other places that really care about kind of this account security posture. If you contribute a code or an API credential to that source, you'll get blocked in the UI and in your IDE saying, hey, it looks as though you've attempted to leak a credential on github.com. We're going to prevent you from making this commit. You can override that, and we're going to walk through kind of what that experience looks like in case you see it on github.com. But this has saved a tremendous amount of time for developers by moving from a reactive stance to kind of a proactive stance. Rather than having to roll the credential and replace it in your code, you can stop right there and just sanitize the Git commit history, identify where you've leaked the token, and then push your commit. So, you know, by sort of stopping you before the credential is public, we save quite a bit of time not having to go to the cloud service provider and change the credential. So this is a quick overview of how GitHub push protection looks if you're in your IDE. So let's say that I've made a contribution and I've left a credential sitting in my code. When I go to push that on the next slide, what you'll see is the standard out that I get in my IDE. So here you can see that, in this alert, I've leaked an AWS access key. It gives me the commit ID where that's located, as well as the line number and file that commit is located in. After looking through that, I can also see a URL that maybe lists out my organization's or the open source organization's policy on how to obfuscate tokens correctly. Maybe they use a product like HashiCorp Vault or Azure Secret Store that they use to keep credentials secure in. If they have some standardization around what I should do with a credential, that URL will be provided to me so that I can understand what the policy is for that project. The last URL I get is an override button. And in certain instances, it may make sense to override this warning. It could be a false positive, although with these push protection patterns, we have an exceptionally low false positive rate. What we're seeing on the platform is less than 1% of these are flagged as false positives. Generally, someone will say, hey, we're using this in tests, or we're going to accept the risks of leaking this credential because it's a demo and we've already invalidated it, or something like that. So if you need to override this warning, there's a URL there that you can use to kind of break glass and push the credential anyways. That will take you to a screen that looks like this, that allows you to select a reason why you're overriding it. And this generates an auditable event for the maintainers of that repository so that they know that this credential went in, that you were the one that pushed it, and that you've left kind of a paper trail as to why you've left it there. If you contribute in the UI, you'll get a very similar experience. All of the same links are here, right? Just a slightly different look, making the edit manually in the GitHub UI. But we've got a problem here. So only half of the 200-ish patterns that we scan for are eligible to be used in this push protection model. If you think about the experience we want to offer you as an engineer on the platform, we don't want to throw these errors and warnings while you're trying to contribute code, unless we're really positive that you're about to make a mistake, or you're going to do damage to yourself by making that commit. As Natalee was talking, there's a lot of tokens that aren't highly identifiable. They kind of optimize for entropy in the token, meaning that there's high randomness, but no identifiable characteristics of the token. Even little things like, a fixed length or a beginning character set or a limited character set, not including symbols, that really helps us identify like, hey, this string belongs to, some service provider as an API credential versus some random salt or hash that may be sitting in the code somewhere else. But we really need the help of kind of the API creator ecosystem, right? Whether you're creating APIs internally at your enterprise or for public services that developers are supposed to use, improving the token format so that downstream identification can happen. So as a service provider, you can do a handful of things with us. One is help us make your secrets more identifiable. And I can review kind of the quick steps that Natalee shared that help do that with your pattern. Two, you can build a service to receive alerts from GitHub and kind of join this secret scanning program. And through doing that, we'll ask you to create a web endpoint that receives a payload from GitHub whenever we identify a leaked credential on our platform. And through that, you can prevent accidental leaks of your credentials and account takeovers that may happen if you were unaware that that token was available publicly. So just a quick recap on what to do with those tokens. Our best practices for token generation include using a prefix. So, in this case, this is that 3-letter GHP. And we alternate those prefixes depending on what service that token is used for. So sometimes you'll see it prefixed as GHO or GHI, depending on what kind of access credential we have. We use that underscore there because it improves the ability to copy and paste the credential. This is one of those steps that people do manually in their workflow. And so we have to think about kind of the broader user experience of copy and pasting this credential. If you use dashes when we go to copy the credential, double clicking it will segment the highlighting on the dash. So you could get, maybe 5 characters, and then it stops because there's a dash, and then another 5 characters. So by using underscore as the thing that breaks up the token string, it doesn't change the way that we copy and paste it. We can double click the whole string and it'll highlight the entire thing. Lastly, we talked about that checksum, and that's really what gives us a really high positive rate on the token. When we identify it, we can validate the checksum and know with a really high degree of confidence that this token came from a particular provider. In this case, it really helps us prevent having to do database lookups. Like, I don't have to take this token and run it against my internal database to understand if this belongs to a user. I can just know that I minted that because it matches the checksum and the trailing 4 characters here. So if you implement these best practices, we can scan for your public tokens really easily. Again, you're the third part of this diagram that Natalee went through earlier. If you're creating a public service for developers, and so you can create an endpoint that will send matches to. When we identify on GitHub.com that there is a credential leak, we'll send you a payload that includes the URL where we think we found it, the line number in that file where we think we found it, and really help you triage with your own user how to roll that credential and prevent any account takeovers. These parts in yellow about revoking the credential or creating an email alert are really up to you as a service provider. If you're providing a service that is kind of mission critical for an organization like maybe a cloud service provider platform, well, you may not want to revoke tokens automatically on behalf of your customers because that could do more damage than having somebody run up some fraudulent charges. But if you're maybe accessing a contact list or some customer data, maybe it's less risky because it's not used in a production application to just immediately invalidate the token. So you'll kind of know what's best for your user community, and we'd ask you to kind of take the payload from us and then implement some remediation steps. This program is all entirely free from GitHub. So if you offer public services to developers and want us to check for your API credential format, we can work with you to build a regex that will identify that token format. We'll help put in place any delimiters and post-processing validation, checking and validating those checksums with you. We eat all the compute, for doing those scans, and we're happy to do that because it just helps secure everybody, on GitHub and also on your platform. Once you build that receiving service, we'll begin sending you notifications of any tokens that get leaked on GitHub. So, in essence, what you're getting is a free disclosure stream from us rather than somebody going to a bounty program and telling you that an API credential has been leaked. We would just send you it anytime that we find it on github.com. We're leaving this slide up for just a minute. If you want to write down that email address, please feel free to send us a follow-up note if you've got questions about enrolling in the program. You want help refreshing your tokens. As Natalee shared, we worked with some of our partners to refresh their credentials, and there's a number of best practices we've learned. API credentials tend to create an implicit contract to users that maybe the length is fixed or that they anticipate a certain character at the beginning or at the end or something like that. So we can talk through how to do the update of your token into like a new format that we can identify pretty seamlessly. And we're happy to help consult on that. So please email us if you run any kind of public developer facing service where you want to protect your users from accidentally leaking API credentials on GitHub. We'd love to have you in the program. And again, this is totally free service that we offer just to the broader development community. I think that one's hidden in the background. That's a dead slide. I was supposed to get a thank you after that. Oh no. We got our version of the slides, but I think this is the end of our presentation here. We'd be happy to grab any questions that folks have here in the chat, or Mel, if you want to come back and wrap with us for a few minutes.
Yeah, for sure. Really great information. Thank you, both of you. Just some quick questions. I know I'm keeping an eye on the chat here. Just some things that I've noted and jotted down. Going back at what I found really fascinating was the vulnerability chart you guys demonstrated a little bit early on. that you guys beat some like, Rapid7. And how can individuals or companies get access to that data if they wanted to go and maybe integrate that into their posture to kind of see what's out there? Where do you recommend they go? How do they get access to it? And what's the cadence do you suggest that they go and take a look at these? I mean, I think it's fantastic information.
Yeah, and to be clear, this isn't like about competing with anybody. I think everybody contributing to identifying vulnerabilities in open source is a great thing. GitHub has this incredibly privileged position to be hosting your open source. And so many contributors choose to disclose security vulnerabilities directly through us. And we're a CVE enumerator, so we'll help validate that vulnerability is real, and then give it a CVE number and do any coordinated disclosure with the maintainer of the project. So this is a totally different feature inside of GitHub, but I'm really glad that you brought it up. Anybody can get access to that data through github.com/advisory or advisories. Yeah, advisories. And I'll put that in the chat here in just a second.
Fantastic.
For you. But that has all of GitHub's public advisory data. We make that available free, so we don't sell that data stream. There's a lot of companies that are like software composition analysis companies or supply chain analysis companies that sort of maybe guard that data more than we do, right? We just make it available to everybody. And there's a project on GitHub called Dependabot. So Dependabot, what that does when it's enabled, you can find this for free, again, in the UI of GitHub. You can set that up on a project and it will look at a manifest or lock file in your repository that lists out dependencies that you have. And then based on how you've configured Dependabot, it'll check that advisory database maybe once a day and say, hey, based on what I know is in your application, we've identified new CVEs that are in your dependencies or transitive dependencies that you may have, and throw an alert inside of GitHub to advise you to update that dependency. You can also configure it to do version updates. So if you just happen to slip 2 or 3 versions behind what is published current, you can also set a reminder to make a pull request to update to the newest version. Those 2 pieces of functionality really just help you keep your dependencies up to date and free of any security vulnerabilities that people are finding in them. All of that's done through automatic PR requests, so it's relatively easy to just hit approve. Once you see that the version update has passed all your PR checks. If you want to publish an advisory, maybe you maintain an open source project. There's a security tab, which is where you configure secret scanning. It's also where you configure Dependabot in the UI, and that has a security notification option where you can file the CVE with us. So the reason we ended up, kind of high in that chart we shared is because people use that feature to disclose security vulnerabilities to us, and that goes to our open source team that validates those vulnerabilities. So that's sort of our process for engaging in common vulnerabilities that we find in dependencies. But definitely check out Dependabot, and maybe we'll come back next year and do a conversation on Dependabot.
Awesome. No, I love it, and I love it. A lot of it too is automated because you can only like get so many inundated notifications from every tool that you subscribe to. So the fact that you have it organized, and then there's a workflow of, I guess, cadence, right, between GitHub and then of course your partners, right? So that was a really well detailed answer. So thanks, Jose. My next question, I don't know if it's really for you or for Natalee. You mentioned a couple of things, partnerships with one in particular, MITRE. Is that more for a development standpoint or more from a security-centric standpoint? I know there's a lot of different threats that go out there, and is it more of like, hey, this is how we can optimize what we're doing, or is it more of like, hey, this is pretty targeted, let me help you understand why these things are happening?
Ooh, can you help me understand a little bit more what you're asking for? With MITRE, I don't know that we have like a direct partnership. They're just kind of another organization that, the government uses to publish CVEs. And so I think they were listed on that slide as, they're kind of the #1 CVE publisher. When we talk about the partner program in context of secret scanning, those are people that are creating API credentials. So this could be like an AWS or a GCP or, Azure, somebody that's offering a cloud service that's accessed through an API token. Where were you kind of thinking?
Yeah, no, and I think, and I apologize if it wasn't clear. I'm thinking more of the matrix, because they have so many different types of like, hey, this is where the matrix is, this is where the threats are, and I want to know where exactly GitHub contributes to that matrix, because they have ones for mobile, they have some from applications, they have some from every different side, right? And I apologize for my noise, I'm getting blown up.
No,
here.
you're good. So you're talking about maybe different threat vectors for
yes, exactly.
vulnerabilities. So GitHub, our approach is really to look at the code that we host on your behalf, right? So most of our tools use a static analysis approach. What we talked about with secret scanning is using, a regex library to scan your code for hard-coded passwords would be kind of the MITRE title, or like, bucket of vulnerabilities that you'd see in OWASP or from, some sort of standardized threat matrix. The other pieces of our security suite are also free to open source projects. And so we have a project called CodeQL, which scans for like the OWASP top 10 and, things like cross-site scripting vulnerabilities or buffer overflow attacks, like that sort of SQL injection, unsanitized user input. All of those types of vulnerabilities get picked up by code scanning, which is a static analysis security testing tool that we also make available. And then Dependabot is really for, the supply chain or software composition use cases. In all of those, we look at the source that we have available and then make a determination about whether or not we think there's a vulnerability present in the code. So I don't know exactly where that maps into MITRE's playbooks, but those are kind of the three big categories that we really focus on with our security tooling.
Awesome. Yeah, you answered my question perfectly. I'm looking at the comments. Don't say anything quickly. One more question for Natalee on alert fatigue. I want to say this is probably every security operations person's nightmare. They come in and they see the same thing on and off. So what are some things from your professional standpoint that can help, enhance or make it more efficient, right? Because it becomes mundane, you don't see the same thing every day, so you don't really catch the bad stuff. So what are some suggestions that you can provide?
Yeah, I mean, really for us, it's, trying to make sure that we're not sending bad notifications on what we're doing, right? So Jose really went into detail about the checksum, having a really strong pattern, the underscore, and a really distinct, I'm losing my words here, prefix. There we go. So if a prefix in a checksum, for example, we have seen that eliminates most false positives. So when folks add those, we're seeing that it's down below 1%, almost near 100% of the notifications are true positives. And that's what we would love to see with everyone, right? As we're working with partners, often when they first enroll in our program, they send us their patterns, we take a look at it, and we give them immediate feedback of, hey, while we're doing some work on our end, here's our suggestions for you to really be able to eliminate how many of those false positives not only are we going to see, but that you're going to get in your inbox, because we don't want to be part of that fatigue at all, right? And that's really why this program is free for everyone. We would love to scan for every pattern that's out there. Anyone that mints tokens, we would love to put your patterns on GitHub so that we can ensure that nobody is able to leak those, take advantage of them. And again, really that prefix and checksum is what's going to keep those bad alerts out.
Fantastic. No, thank you for that. That's always something I ask when I hear it coming from a security operations background. That was one thing that I was always looking to make better, right? Or to make it more efficient. So that was very helpful. Any last closing words for our audience, Jose or Natalee?
I just want to say thanks to everyone that has joined us today. And again, please reach out to us. We would love, like I said, to have all the token patterns out there, and look forward to attending more sessions myself and hearing from others.
Yeah, no, thank you. We absolutely love having you guys as part of the API Security Conference. I always enjoy this chat and really enjoy the presentation from both of you today. So thank you.
Thank you.
Thanks, Mel.
Take care.